This second part of 6.4 is the same idea, except we're going to take away the pi. So pi allows us to give exact solutions because just by its nature, the fact that circumference divided by 2 times the radius gives you this irrational decimal is kind of too bad. It's too bad they couldn't have found something else in nature that would come up with this nice exact number. But the reality is that one distance around a circle is pi, right? Which is 3.14, which means that radian measure is like, when you don't take it with the pi's, it's kind of horrible because 1 radian isn't a third of the way to 180 degrees, right? It's like a little less than a third of the way, which kind of makes things super complicated, okay? But what we just are going to look at here is like 8.5. Where would I put 8.5 onto this circle, right? So 8.5 is 8.5 radians, and which quadrant would 8.5 be? Now it says sketch a unit circle and mark the appropriate location or approximate location. Super approximate, okay? I really just want to know what quadrant 8.5 is going to be into. And so all I'm trying to get across to you is that if I was to draw, or if I was to put into this circle, instead of putting like, pi by 6, pi by 3, pi by 4, pi by 2, if I actually put the numbers, like what they are, pi is 3.14, ... Okay, so if we went half of that, pi by 2, I could plug into my calculator, pi divided by 2 is 1.57. So in here we've got 1.57. The bottom would be 3 pi by 2. So 3 times pi divided by 2 gives me 4.71. And then all the way around would be 2 pi. So 2 times pi, which is 6.28. And so where would I put 8.5? Well, I don't know yet. So now we have to go around again. So if I do 6.28 plus 1.57, that means that up here we've got approximately, because all of a sudden I've rounded, but approximately 7.85. To go, another cycle to 3.14, I would do pi, I'd do 2 pi actually, 2 times pi plus another pi, right? So I'm finding a coterminal angle. So my calculator's off. 2 times pi plus pi gives me 9.42 here, 9.42. So 8.5 is somewhere between 7.85 and 9.45. I don't care where. Oops. Not like math though, I gotta go to the vertex. There we go. Somewhere in there, okay? Approximate location. Approximate location is somewhere in quadrant 2. Sweet. So now where would I put 1.3? Well, 1.3 is easier. I should have done that one first. 1.3 is somewhere between 0 and 1.57. So it would be somewhere in here. And again, super approximate. Actually, you know what? I think it would be a little bit closer to 1.57. Maybe like that, right? Just numerically, it makes sense. So this would be 1.3. 1.3 is in quadrant 1. So all I really want to show you here is that, what we looked at in the last video was exact radian measure. This is approximate radian measure, which is literally plugging in the pi's to your calculator and getting a decimal solution, which I think ruins radians, to be honest. And the other thing I want you to notice is that, how did I know this wasn't a degree measure? Well, there's no degree symbol. So anything without a degree symbol is considered to be in radians. Okay, second last part of this video is converting from degrees to radians and radians to degrees. So to do this, what I want you to recognize is that 180 degrees is equal to pi radians. So we use this fact to be our conversion. So we say that 1 radian is equal to 180 divided by pi, right? And 1 degree is equal to pi divided by 180. So what do we do with that? Well, we can do it as a conversion. So if you know your degree measure, you can times by pi and divide by 180 radians, and you can convert. If you're in radians, you can times by 100 and divide it by pi and convert to degrees. I can't, to have that written somewhere, okay, and then I gotta look every single time. Am I multiplying by pi and dividing by 180, or am I multiplying by 180 and dividing by pi? It's really simple to remember if you think about the principles of radian versus degree measure. Radian measure, you want a pi. So you're gonna put the pi on top. So this is going to be 45 degrees times pi divided by 180. If you're converting from radians to degrees, you want to get rid of the pi. So you're going to put the degrees on top and get rid of the pi. That's how I remember it. So I always remember it's 180 to pi in some ratio, and then I think of which one goes on top depending upon whether I want the pi or I don't want the pi. And then you simplify. So this would be 45 pi by 180, and you no longer write the degree symbol because we're no longer in degrees. And then you simplify. So for me, you could look at a number that divides into both 45 and 180, which is actually 45, or you can use your fraction button on your calculator to do 45, and then you can use the A, B over C button or the D over C button to say 45 over 180, and then it'll simplify to a quarter. So 45 degrees is equal to pi by 4. But I wouldn't want to do that every time, and I don't want you doing that every time. I want you to see like 45 degrees and be like, oh, that's quarter of the way to 90. Got it. Or sorry, half the way to 90. Pi by 4. Or quarter of the way to 180. Got it. Okay? But something like 75, I don't know. So I'm going to times by pi, divide by 180, and then I'm going to simplify my fraction. So 75 over 180 simplifies to negative 5 pi by 12. And then there's these weird tricky ones that I had to show an example of because I looked at the textbook and was like, what? What do you want me to do with that? Well, nothing. They just want you to do this. So you would put your answer as 237.71 pi over 180. Your textbook in the back says this is the answer, but it also says or. Because technically this is super wrong. You're not allowed to have a decimal in a fraction. So if I wanted to make 237.71 no longer be a decimal, I would multiply by 100. So if I multiply my numerator by 100, I get 23771 pi over 180 divided by or times by 100 is 18,000. So the back of the book will say or. Technically, I guess it accepts either. If I had to pick one, this is a proper fraction. This is not. But it is radians, and they're not exact anyway. Okay, so then if we want to go from radians to degrees, this is the beautiful thing about changing from radians to degrees, is you get to go boom, boom. Pi divided by pi is 1. It is gone. What am I left with? Well, 4 divided by 3 times 180, or 4 times 180 divided by 3, and I get 240 degrees. Okay, pause the video, give these two a go. This one would be times by 180 over pi. Again, the pi's go away. I'm left with negative 3 times 180 divided by 4, which is negative 135. Don't forget your degree symbol. And then lastly, this guy, 180 divided by pi. You're just plugging it into your calculator. So negative 0.4 times 180 divided by pi, because I couldn't get rid of the pi. So I'm giving an approximate answer. Round the answer to 2 decimals where appropriate. So approximately 22.92. Don't forget your degree symbol. All right. Last 2 things before we end this video. So this next one is about coterminal angles. So we want to find a positive and a negative angle that are coterminal with 4 pi by 3. Now 4 pi by 3 I know is down here, right? This is 4 pi by 3. You can think of it as 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, or maybe you start seeing that it's 1 pi by 3 past 3 pi by 3, whatever you want, okay? We want to find an angle that's coterminal with this. Well, what does coterminal mean? Coterminal means we want to find an angle that shares the same terminal side. So I can get that by going all the way around and then back to 4 pi by 3. Which would mathematically mean that to 4 pi by 3, I would add 1 full rotation of 2 pi. Now I need a common denominator. So 4 pi by 3 plus 6 pi by 3 gives us 10 pi by 3. If I wanted to find a negative coterminal angle, so in other words, I'm going to read in a clockwise direction, just to there, right? What you're going to do mathematically is you're going to take 4 pi by 3, and you're going to subtract 2 pi. And again, common denominator, this would be 4 pi by 3 minus 6 pi by 3, which is negative 2 pi by 3. If I wanted to find more, I would just keep adding 2 pi or keep subtracting 2 pi to find more coterminal angles. The next two terms are complementary and supplementary. Could you do this without me saying anything, right? Complementary angles add up to pi by 2 or 90 degrees. So if we have an angle like pi by 6, right? We want to find an angle that would add, I should use theta, an angle theta that would add with pi by 6 to give you pi by 2. So theta plus pi by 6 gives you pi by 2. So to find theta, you just do pi by 2 minus pi by 6. Which I'm going to create a common denominator, so I'm going to multiply top and bottom by 3. So this would be 3 pi by 6 minus 1 pi by 6, which gives you 2 pi by 6, which simplifies to pi by 3. So pi by 3 is complementary to pi by 6. All right, last thing is supplementary. So this was complementary. I should write that somewhere. Complement. Supplement. Supplement means that they add up to 180. So if you think about it, here I've got my lonely little pi by 6. I want to find an angle theta that adds to pi by 6 to give you pi, or 180 degrees. In other words, theta plus pi by 6 is going to give me pi. So to find theta, I'm just going to do pi minus pi by 6. I'm going to create a common denominator, so 6 pi by 6 minus pi by 6 simplifies to 5 pi by 6. And that's it. All right, that is part 2. Have fun.